Hi everyone, I am Mr. David and today we are looking at velocity time graph. Okay, velocity time graph plots an object velocity against time. It shows how its velocity changes over time. All right, so it visualizes the object velocity against time, the object speed and direction over a period. So how does it change over a period of time? Now, what are the informations you can obtain from the graph? Number one, we can get acceleration, and you recall that there's the formula for acceleration equals to a equals to v minus u over t. That is a equals to final velocity minus initial velocity over time. Now, retardation too, we are going to use the same formula, but then when you use this formula, you are going to get a negative value. All right, so you just multiply it by minus to get a positive answer, or just ignore the negative value. Okay, so that's how to look for the retardation. It's almost the same formula with acceleration. Now, total distance traveled. Now, total distance traveled is the area of the graph itself. Does it come? Yes, you can get the area in various shapes. Sometimes it might be a trapezium, or rectangle, or a triangle, even a square. So we are going to be using all these areas, albeit the area of trapezium is half into bracket a plus b close the bracket h. Now area of rectangle is what? Length times breadth. Area of triangle is half times base times height, and area of a square is length times length. Now another thing we can also derive from uh, we can also obtain from the graph is the average speed. The average speed. Now, what is the average speed? This is just basically total distance over total time. So total distance traveled over total time is our formula for the average speed. Now let's look at few examples. Example one. Example one. A car starts from rest and accelerates uniformly for 20 seconds to attain a speed of 25 meters per second. It maintains this speed for 30 seconds before decelerating uniformly to rest. Total time taken for the journey is 60 seconds. Now, sketch a velocity time graph for the motion. That's our first thing. So, how do we? And the next question is to use the graph to determine the total distance traveled by the car, deceleration of the car, acceleration of the car, and average speed. Now, how do we make sketch a velocity time graph? It's very easy to do. Now, let's just since our highest velocity here is 25 meters per second, we are going to make a sketch of velocity against time. So let me number this line as 25. The next one should be 20. The next one should be 15, 10, 5, and 0. Okay, so we draw a line like this. Good. Now we'll make another line like this. Now, you know that what you have on this side is your velocity on y-axis, and the unit is meter per seconds. Now, on x-axis, what you have here is your time, and your time is in seconds as well. Okay. Now, let's now interpret uh, the statement here. Say a car starts from rest, so your 0 is the rest. Start from rest to attain a speed of 25 meter per seconds. That means you are going to draw this line up to 25. 25, all right? Yes, up to 25, because the statement states that a car starts from rest and accelerates uniformly for 20 seconds to attain a speed of 25 meters per second. So it means at this point now, you trace it down, you should be having 20 seconds on the x-axis. So 20. Now, it maintained this speed for 30 seconds. That is uniform. Now, from year to year, it maintained a uniform speed. This is the uniform speed here for 30 seconds. So 30 seconds plus 20 seconds, that will be 50. So we're going to trace it down to 50. All right. Then we are told that it decelerates uniformly to rest, and the total time taking is 60 seconds. So it means that if the total time taken is 60 seconds, from here it decelerates from 25 down to 0 at 60 seconds. Okay, now let's interpret the graph. This side from year to year is acceleration. Now this is your uniform speed of velocity. Now from year to year is your what? Retardation or deceleration or retardation. Okay, good. Now let's solve the problem. So we should use the graph to determine the total distance traveled by the car. So the total distance traveled by the car is the area of the graph. All right. Now, if you look at this very well, what does it look like? Oh, guess what? It looks like trapezium, actually. Trapezium. So that means to find the area, to find total distance travel, let's say total distance traveled will be equals to what? The area of a trapezium. Okay, this half into bracket a plus b close bracket height. Okay, now where is our a? For me, I'll make this my a. Now, how do you get your a value? From here, from this point to this point is your a. Okay, so that means from 20 to 50. So 50 minus 20 is what? Give you 30. Now your b is from this point to this point. So that's 60 because it's going from 0 down to 60. Now, how do we get our height? Our height, h, is what? Is the height of the graph. That's from 0 to 25. That's 25. Okay, so we're just plotting our values there. Half to bracket a is 30 plus 60 to bracket 25. If you do this math, you are going to get 1125 meter. Now, unit of distance is what? Meter. So this will be your answer. Now let's move on to the next question. They say we should calculate the deceleration of the car. Deceleration. So how do we get that? It's just the same thing as acceleration, but not really the same. You use the same formula. Now, this side is your deceleration. That is moving from 25 down to 0. So in this case, your final velocity will be what? 0. Your initial velocity was 25. Then the time it took, time taken will be 50, 60. You have 50 and 60. 60 minus 50 is what? 10. Okay, so if you do this, you are going to get minus 2.5 meter per second square. Okay, but we cannot get negative values. So that's why I say the acceleration is negative of acceleration. So our answer is 2.5 meter per second square. This is our answer. This is our deceleration. Now let's move on to the next question. The next question is to look for the acceleration of the car. So how do we do that? Now, how do we find the acceleration? So acceleration equals to v minus u over t. Now, what is our final velocity? So it's moved from 0 to what? 25. So this 0 is our initial, our final is 25. That is u equals to 0, v equals to 25. So that's, then we now have 25 minus 0 over. So what's duration, all the time taken to reach this velocity is just 20 seconds over 20. So if we do that, that will give us 25 divided by 20, which is 1.25 meter per second square. Okay. Now, the last question is the average speed. Average speed. Average speed. So D average speed. So what's the formula for average speed? That's the total distance traveled over total time taken. Now, what's our total distance traveled? The answer is here. That's 1125 meter divided by total time taken, 60 seconds. I stated in the question already. Total time for the journey is 60 seconds. Then divided by 60. If you plug into your calculator, this is going to give you 18.75 meter per second. Right? That's how to do that. Let's look at the second example. Yeah, okay, guys. Let's look at the second example. Example 2. The diagram below illustrates the velocity time graph of the motion of a body. Calculate total distance covered by the body. Okay, in this case, we already have the diagram. We don't have to sketch any diagram. Okay, please, there should be time here, time seconds. Now, we have a graph in this manner, and we have uh, 3 portions already on the graph, A, B, C. So for us to calculate the total distance covered by the body, we know that we need to find the area of this shape we are having here. Now, if you look at it very well, this does not look like a typical trapezium. But we can always do it this way. We can solve for A first, then solve for B, then solve for C. Now, so area A, let's look at the distance under area A. Okay. Now let's picture this out. We are having something in this manner. You have something like this, like this, like this, like this. Yes. That's what we have here. Now, from year to year is what? Is 5. That's what we have. Okay. Now, yeah, what are we having here? We are having from 5 down to 20, sorry, from 0 to 20. So this is 20. Now from year to year, that's 0 to 10. So that's side is 10. Now if you twist the diagram like this, it makes this looks exactly like a trapezium. That is, this will be our A, this will be our B. All right, this will be our height. Okay, so if you bend it like this, it looks like a trapezium. So we just go with our area of trapezium, that is half into bracket A plus BH. So that will give us 1 over 2 into bracket A. Our A is what? 10 plus our B is what? 20. Then our height is what? It's 5. Okay. 10 plus 20, that's 30. So we have half in the bracket 30 and 5. Half in 30, that's 15. So 15 times 5 will give us 75 meter. That's how to deal with the area under A. Now, the area under B, what does it look like? As I mentioned earlier on, we might have something like this, probably in form of square or rectangle. Okay, so what area do we have under B? So we write B, then we also draw it out like this, so we don't make mistakes. Please don't mind my sketching. Okay, so now from year to year is what? 5. Good. Now the height, that's from 0 to 20. So this is also 20. So that means all the area, this look like a rectangle. So all the area of a rectangle, that's length times breadth. So that's length times breadth. That will give us our length is our length here is 20 and our breadth here is 5. So that if you do that 20 times 5, you're going to get 100 meter. Now we cannot focus on the last area, that is C. C, that was gives us a rectangle, triangle rather, a right angle uh triangle in this case. Now, so from here to here is how many? 5. Okay, and our height is also 20. And we know that our area is what? Half times base times height. So that will be half into bracket times 5 times 20. Okay, just do 2 here 1, 2 here 2 here 10. So 10 times 5 equals to 50 meter. Good. So we can now get our total distance traveled. So our total distance will be equals to A plus B plus what? C. So that's 75 meter plus 100 meter plus 50 meter. Okay, so what is that going to give us? What is that going to give us? That's going to give us 225 meter. Also, you may not have to do B and C separately, because if you come here and look very well, this look exactly like trapezium. So you just use the formula, that's half times A plus B H to calculate it. So once you are done calculating, you now add everything together. Thank you.